In March 1945, smoke drifted across the Rhine. German artillery had reduced every bridge from Cologne to Wesel to twisted metal. For weeks, the river had stood as an armored wall, halting Allied armor at its edge. Then, beneath scattered flares, engineer units began linking narrow steel panels by hand. Each weighed 600 pounds, pinned through by hammers that rang against the current. Within hours, a full span touched the opposite bank. Shermans waited with engines idling, exhaust curling white in the cold. One by one, the tanks rolled onto the deck plates, 30 tons pressing into timber and steel. Tracer fire cut across the water. German observers called it madness. No bridge could stand under bombardment. But the trusses held. At dawn, columns of tanks fanned east, their silhouettes vanishing into smoke. Within 24 hours, 90 German armored vehicles lay destroyed along 10 miles of shoreline. The crossing that could not exist had broken the final defense of the Rhine. The idea had once been mocked as reckless, too light, too quick, too simple. Yet a structure built from geometry and repetition had outlasted fire and disbelief. They had called it crazy until it crossed the river. By late 1944, the Allied advance slowed to a crawl. France was free, but rivers and wreckage replaced open ground. Each retreating German unit destroyed bridges behind it, leaving gaps too wide for tanks and too deep for pontoon gear. The Rhine loomed as a final barrier, broad, swift, and fortified. Engineers called it the Wall of Water. German command called it their shield. The Wehrmacht mined both banks and aligned 88mm guns along every crossing. Observation posts stood on high ridges, with orders to fire the moment bridging crews appeared. The river ran nearly half a mile wide in places, its current swollen by winter rain. Allied pontoons folded under 30 tons of Sherman weight. Fixed bridges needed cranes and calm weather that war never allowed. Speed, the advantage that had broken through France, was gone. In this deadlock, one engineer refused the logic of impossibility. Donald Bailey, a quiet officer of the British Engineer Corps, had been designing modular spans since 1940. He believed bridges could be built from repeatable panels, not heavy beams. 10-foot sections, 5 foot high, joined by a single steel pin. 2 men could lift each piece. 20 could build a crossing before dawn. The concept sounded absurd to superiors. Light bridges failed under armor. Heavy bridges took months. Bailey proposed both. Light in form, strong in result. His first models bent, pins sheared, planks split. The workshops mocked his persistence, calling it a toy bridge. Yet he refined the trusses, recalculated load paths, and redistributed stress through layered geometry. Tests at Christchurch in 1941 changed the laughter. A 40-ton Churchill tank crossed without visible strain. The bridge flexed, but the metal returned to shape. Factories began stamping parts, each to the same gauge tolerance, plus or minus 1/16 inch. 1,000 sections shipped weekly under blackout. By 1944, Allied depots stored crates marked bridge, portable, steel, class 40. Thousands waited behind the lines of France, ready to turn rivers into roads. Still, the Rhine stood untouched. The German staff believed the river's width and firepower made it immune to engineering. Allied commanders hesitated. A single failed crossing could erase months of progress. The winter dragged, and the front stiffened. Every soldier on the West Bank saw the same current and wondered how to cross it alive. Then came the plan, Operation Plunder. Engineers would build under fire, assemble by hand, and open a tank route in hours, not days. The idea belonged to Bailey's mathematics as much as to military orders. Geometry would fight artillery. Precision would replace power. Across Belgium, trucks loaded their cargoes, steel, pins, deck plates, cable. In England, new sets of panels were crated and labeled for final shipment. The last natural fortress of Germany would face an industrial weapon that did not explode. They believed distance was safety. It was an error in math. In the winter of 1940, while London burned under air raid sirens, the British War Office searched for a bridge that could move with war. Conventional spans needed cranes, riveters, and still air. luxuries no front could spare. Roads could be repaired, but rivers stopped armor cold. The Royal Engineers wanted something a platoon could carry, build, and cross before the enemy regrouped. Donald Bailey, a civil engineer from the Ministry of Supply, drafted an answer built from repetition. Instead of massive girders, he proposed modular frames, 10 feet long, 5 feet high, joined by a single pin. Each identical, each portable, each part of a larger equation. 2 men could lift a panel. A dozen could raise a span. Strength would come from geometry, not mass. At Christchurch, testing began. 10 soldiers received a sketch and a pile of parts. Without cranes, they lifted, aligned, and pinned the sections into an 80-foot structure. Within 2 hours, a 3-ton truck crossed without deflection. At dawn, a 40-ton Churchill followed. The deck plates vibrated, but the bridge held. The observers wrote one line in their report: "Structure sustained full load, no deformation." The design had proven what Bailey called strength through duplication. By mid-1941, it entered production. Each component demanded exact tolerance, holes drilled to within plus or minus 1/16 of an inch. Factories adopted a universal gauge so panels from Glasgow could fit those from Cardiff or Montreal. One misaligned pin could halt an army. The design's strength was precision. Industrial lines adapted overnight. Steel mills that once shaped armor now rolled the bridge's lattice girders. At Dorman Long, Camel Laird, and BSA Works, shifts ran 18 hours. Over 500 subcontractors produced parts. Monthly output exceeded 120,000 tons of steel. Crates left assembly yards labeled Bridge Portable Steel Class 40. Each contained trusses, transoms, and deck sections totaling 20 tons, light enough for a convoy, heavy enough for war. Field data recorded the details. Load rating 45 tons, safety factor 2.5, allowable deflection under full load, less than 1 inch per 20 feet. Stress at main pin joints reached 2,000 psi. Material yield strength measured 50,000 psi. Zinc chromate protected the alloy from corrosion. For the first time, engineering math had been forged to outlast artillery. Ease of use made it universal. Components could be stacked, doubled, or tripled for heavier tanks. Transoms adjusted for river depth or bank height. Crews needed no cranes, just hammers and muscle. Every soldier could learn its pattern: pin, truss, transom, deck. Once memorized, it became rhythm. In 1942, the design reached combat in North Africa. The 8th Army used it to cross wadis under fire. Reports confirmed assembly times as short as 3 hours for 100-foot spans. The bridge survived more than 1,000 tank crossings before replacement. In the desert, it endured heat above 120 degrees Fahrenheit and dust that buried every moving part except its steel. By 1943, the Allies standardized it for global use. The Bailey Bridge Class 40 became a logistics weapon. At Aberdeen Proving Ground, U.S. engineers tested it for the M4 Sherman. Maximum stress 2,300 psi, assembly rate cut by half compared to pontoon models. The Americans adopted it immediately. The bridge crossed borders as fast as the Army itself. Bailey refined the design again: longer spans, stronger bottom chords, and interchangeable decking. Each section carried 12 man-hours of labor and 7,000 calculations of stress. Behind every bridge was arithmetic turned into steel. By early 1944, the network reached maturity. Trains hauled pre-packed kits across Britain. Each convoy carried 2 bridges, one for immediate need, one as reserve. Assembly manuals were printed in 16 languages for Commonwealth forces. Factories in Canada and the United States produced identical sets. The bridge no longer belonged to one nation. It had become the shared vocabulary of engineering under fire. On proving grounds, soldiers practiced blindfolded drills, assembling panels by feel and counting pins by touch. They built in darkness, tore down in daylight, and built again faster. The war had made the act of bridging an industrial reflex. Technical memos from the period read like production logs. Average construction rate 180 feet in 6 hours per 50 men. Continuous service load 45 tons. Joint temperature rise less than 5 degrees Fahrenheit per hour. Each figure confirmed what Bailey had written in 1940. The bridge must be built faster than it can be destroyed. That sentence became policy. Planning staffs learned to compute advanced speed not in miles per day, but in feet of bridge per hour. Each engineer unit measured victory by the span it could complete before dawn. By the time Allied forces massed for the Rhine in 1945, more than 2,000 Bailey bridges stood across Europe. They linked supply lines, carried tanks, and filled maps with gray lines drawn over blue water. They were never named, only numbered. Yet each one defined a step of the war's advance. The crazy bridge that officers once dismissed as fragile had turned into a machine of certainty. Every rivet counted, every panel interchangeable, every crossing predictable within minutes. It was not art, nor heroism, nor luck. It was applied math moving across the continent. Every hour was measured, every part counted. By February 1945, the Bailey system moved like ammunition. Crates left the Midlands in blackout convoys, crossed the Channel before dawn, and rolled toward forward depots under tarps, marked only with white numbers. Drivers learned weight by habit. Each truck carried panels stacked by order of use. The first piece of the bridge loaded last. The movement was mechanical, the precision industrial. The river ahead waited for arithmetic. Engineer sections trained behind the guns on frozen fields. 2 men lifted each 10-foot panel, 4 locked it into a truss, 1 counted the rhythm. Pin, transom, deck, pause, pin again. Crews rehearsed until muscle memory replaced thought. A full span could be built blindfolded. Every motion existed to steal minutes from artillery. The bridge had to appear before the enemy could react. Supply officers rewrote logistics to match this speed. Kits were inventoried not by crate, but by bay, a measured unit of structure. Loading lists ran in reverse sequence, so the first component to touch ground would be the first needed. Trucks carried ramps on top, cables coiled beneath. Recovery crews followed with spare pins and split rings. A single missing clip could halt a division. Logistics had become combat's invisible front. The Rhine rose with thaw and rain. Recon units measured its current with weighted lines and watches. 5 feet per second near midstream, 8-foot banks, gravel bed, moderate scour. Those readings dictated launch angles and anchorage. Engineers worked from these numbers as others worked from maps. In Bailey's War, water depth equaled range, flow equaled resistance, and geometry equaled survival. Gun lines advanced to screen the chosen crossing sites. Field artillery fired smoke. Searchlights turned against low cloud to reflect light over the work zones. The night became a gray ceiling of vibration. German gunners listened for hammer blows through the fog and fired by ear. When shells landed short, men froze until fragments passed, then counted back into rhythm. The bridge grew bay by bay. Winch trucks hauled the half-assembled truss onto rollers. Steel cables stretched tight, whining under load. At full pull, drum speed reached 600 RPM. The span slid forward until its nose reached the far bank and bit into mud. Shouts ran down the truss like current through a line. "Hold! Pin!" The pins dropped, the deck steadied, and the river lost its boundary. Operational notes recorded the crossing in data, not narrative. Average build rate, 180 feet in 6 hours by a 50-man team. Deck loading, 500 pounds per square foot without distortion. Stress at joint pins, 2,000 psi under continuous launch. The numbers read like machine specifications. Each figure was another proof of controlled motion amid chaos. Infantry guarded the near shore, rifles angled toward dark water. Patrols cut demolition wires left in reeds. A single shape charge under a ramp could erase the night's labor. In quiet minutes, sappers heard the river slap against piles. In loud ones, they heard nothing but hammer and pin. The bridge tolerated no confusion. Every command reduced to one syllable: lift, lock, drive. Counter-battery crews hunted the 88S that tracked sound instead of sight. When tracers arced above the fog, Fighter bombers from the 9th Air Force struck their grids within minutes. Coordination became mechanical. Each bay completed meant new protection from the sky, a contract between physics and timing. On the roads behind, the flow thickened. Ammunition trucks waited with engines idling, lights blacked, tank battalions staged in orchards, their guns shrouded. Commanders marked routes on barn doors in grease pencil, crossing lane, follow lane, reserve. Schedules were timed to the minute, then rewritten as rain turned soil to pulp. The bridge line adapted faster than the weather could ruin it. Training turned to execution under flares. Crews worked in rubber-soled boots for the grip on wet planks. Lanterns were hooded to narrow slits. Each squad leader carried a pouch of spare split pins. When one fell into water, another appeared before the delay reached the far end. Efficiency was measured in seconds, saved, and lives kept moving. The last bay locked into place near midnight. Ramps dropped, edges sealed with timber wedges. Sappers spread sand for traction, brushed water off planks, and stepped aside. The first truck crept forward, its tires whispering over steel. Deflection measured less than 1 inch at midspan. A second vehicle followed, then a bulldozer pushing debris clear of the exit road. The process had no pause. Throughput tables waited on a crate at the control point. Target flow, 40 vehicles per hour initial, 60 when spacing stabilized. The officer in charge, helmet chalked with Bridge C, listened for a single high note from the truss. None came. He raised a gloved hand and signaled. The first Sherman rolled onto the deck. The bridge answered with a low metallic hum, deep and steady. They built by number, then moved by number. Smoke drifted across the current. Headlights glowed dim under covers. The span swayed fractionally and returned to center. Each tank left the bridge faster than the one before. The water below boiled with fragments of light, tracer and reflection merging into one moving band. By 3 a.m, engineers logged final data. Continuous load tests showed less than half-inch settlement at midspan. Anchor cables maintained rated tension. Ramps compacted within tolerance. The note entered the record in calm handwriting. Bridge open for armor. Below it, one more line. Begin traffic at 0330 hours. First light touched the river a faint silver. An officer walked the full length, tapping pins with a hammer. Each clean ring meant alignment. Any dull tone meant replacement. None sounded dull. He paused midstream, glanced east, and saw the faint silhouettes of tanks waiting in orchards. He turned, lifted a hand toward the near bank, and spoke the only order needed. Phase 2. Move armor. They built, they launched, they advanced. The river had become a road. The first troop crossed at interval. Track shoes clicked on deck cleats, then settled into a steady hum that ran the length of the span. Guides stood at the curbs with flashlights hooded to a slit. Lane width held at 12 feet from curb to curb. Drivers kept the chalked center line. Speed stayed near 6 miles per hour to limit sway. The bridge flexed, recovered, and went quiet. Control concentrated beside the near ramp. A sergeant marked hulls with a grease pencil and a board. Flow rose as spacing normalized. 60 vehicles per hour became the working rate by mid-morning. Call signs and axle loads went onto the clipboard. The engineer captain listened for any high note from the truss. Iron speaks when strain is wrong. The deck stayed low and even. The sound stayed clean. Maintenance teams rotated onto the structure without stopping the stream. One man tightened split rings with pliers. Another tapped pins and felt the return through the hammer. A third swept grit from wet planks so rubber pads could hold. Exhaust heat and wind dried the surface. At mid-span, a corporal checked bearing shoes and wrote a short line. Settlement within limits. No heat color on pins. Continue flow. Approach roads widened under a small bulldozer. Corduroy logs vanished beneath crushed stone as ruts grew shallow. Military police cut bypass lanes through hedges and posted distance boards. A recovery truck idled near the far bank, with a tow bar already pinned. If a tank stalled on the span, the next vehicle would push on signal. Hesitation was risk. The rule was simple: keep the line moving. Enemy guns learned the timing by sound and fired by habit. Counter-battery crews answered from plotted grids at the first flash. A forward observer on the near bank read clean digits into a field phone. Minutes later, the far bank fell silent again. When shells struck near the ramps, sappers pushed fresh earth into crater lips and tamped them flat. The repair took minutes, not hours. The rate held. Air cover thickened as morning cleared. Fighters roamed the high line and slid down at call. Air controllers used short words and fixed numbers. The call sign for the bridge never changed. Rockets framed the edges of German movement across the meadows. For a time, the sky quieted and the queue lifted by one notch. The truss accepted the change without complaint. The plan regained its minute. By late morning, a second span launched upstream where the banks drew closer. The two bridges shared approach roads but split flow by unit. Light vehicles took the new deck to pull fuel and ammunition forward. Heavy traffic stayed on the first span. Throughput rose with the second lane. The river ceased to be a single choke point. It now moved like a road with two clear lines. Fuel bowsers crossed with guides on foot and fire blankets ready. Each truck carried a number stenciled on the tailgate. The control point announced those numbers on a handset and logged the times in one column. A tanker company due at noon arrived ahead of plan. The bridge chief wrote one more line on his board. Priority loads complete, armor ready for distance. The schedule remained a weapon. The far bank opened into firm ground. A dozer trimmed the exit and metalled the ruts with fresh stone. An engineer officer walked the first 200 yards with a folding rule in his palm. Rut depth stayed within inches. No matting required. Military police posted a sign with 2 words in block letters. No halts. The road bent into a copse and vanished. The flow did not slow. Radio nets carried a new message near midday. Phase 3 began as 2 battalions cleared the far side. Tanks fanned along lanes cut through orchards and hedgerows. Control shifted from crossing rate to depth of advance. A liaison officer handed the bridge captain a typed note. Hold rate until 1600 hours, alternate columns after that. The captain pointed to the board and nodded once. Heat built on the steel by early afternoon. A crewman brushed the deck with his glove and checked for resin that could slick the surface. A water tender crossed each hour to damp dust at the ramps. Tire smoke and oil hung low across the deck. Men at the pins drank in 2 quick sips and returned to tools. The count on the board turned 3 digits and kept climbing. Technical checks never stopped. A gauge showed cable tension holding near rated pull. A thermometer taped to a post read 48 degrees Fahrenheit at deck level. Pin bores remained within tolerance. One joint at midspan developed a faint click under load. A corporal slipped a thin shim into the seat and killed the note. The truss answered with steady silence. The numbers matched the book again. At 14:30, a half-track lost power on the crown with its nose just over the brake. The control point signaled a flat palm to hold. A Sherman eased forward until tracks touched the rear bumper and pushed. The pair crept down the far slope and cleared the lane. The pause marked 90 seconds on the board. The rate recovered in 2 minutes. The span never closed. The plan held. Upstream sluices reduced flow, and the midstream chop fell away. Sappers eased a downstream anchor and reset it to a tighter angle. A plumb line showed drift toward the far bank at the crown. The correction drew the deck back to center. A note went into the log with time and initials. Every action left a trail for the next crew. The machine recorded itself as it worked. By mid-afternoon, the logistic wave reached its crest. Ammunition trucks rolled with tailgates sealed by wire. Water trailers and field kitchens followed. Repair teams crossed with lathes bolted to truck beds and tool chests chained shut. A spare power pack for a tank sat on a low loader like a crate of iron. The bridge turned every need into motion. The queue behind shortened for the first time. Reports from the far side began to change tone. Recon elements marked enemy armor beyond a low ridge and called likely contact within the hour. The bridge command thinned light traffic and pushed a final block of tanks through. A single figure stood beside their call sign on the board: Priority. The wind freshened and carried the smell of wet wheat across the water. The day leaned forward. Engineers reset for the next hours like a factory changing shifts. A fresh team took the near ramp. Another relieved the mid-span crew. A third walked the far ramp with wrenches ready. The bridge chief checked his watch and wrote the handover time in a tight hand. He looked along the stream of vehicles and then down at the water. The span had become ordinary. That was success. Late light found new marks on the deck. Steel showed scuffs where track shoes bit and slid a fraction. Timber at the curb darkened with oil. The sound settled into a constant band. Track on plank, engine at idle, a hammer every few minutes to test a pin. A runner brought a paper from brigade. The last block of armor would clear before evening. Supplies and wounded would follow. As the final troop crossed, the control point shifted to alternating lanes. Fuel went east on a measured cadence. Wounded came west with headlights hooded to slits. The count board split into two neat columns. Military police opened intervals and let the line breathe. The bridge chief walked the length with his sergeant and noted every joint that wanted attention before dark. Work would slow, not stop. In the trees beyond the far bank, tanks idled low. Crews checked sights and rations. Infantry climbed onto decks and sat with helmets pushed back. Orders moved down the lanes in folded slips. The ridge beyond the meadows held shapes that did not belong to land. Turrets turned by degrees. Radios coughed and cleared. The river, for a moment, had nothing more to say. The ground would answer. Spare panels went onto skids and disappeared beneath tarpaulins. A last inspection found no heat discoloration, no bent transoms, no fretted pins. Deflection remained within the book. Anchors sat where they were set. The bridge stood as it had stood at dawn, only dirtier and more used. Night crews lit hooded lanterns and laid tools in rows. The day crew stepped back and faced the east. By evening, the span had moved a regiment and its tail. The logbook closed on a single line of print. Total crossings exceeded plan by a clear margin. No structural failures recorded. The river had been measured and made to serve. On the far side, armor settled by phase line an hour. When darkness took the banks, the last trucks rolled with quiet lights. The crossing phase was complete. By night, the balance had shifted. Dawn rose gray over the Rhine. The water was calm, the bridge dull with oil and mud. Every plank carried the mark of steel treads, each joint blackened from exhaust. Along the far bank, armored units waited with engines already warm, muffled under tarps. Their silhouettes stood against fog like a row of low buildings. The night silence ended with a signal flare that burned white through the mist. At 0700 hours, the first Shermans moved. Each tank kept 10 seconds apart, treads scraping on deck cleats that rang like metronomes. The bridge shuddered, then settled to balance. Engineers on the near shore watched through binoculars, tracking deflection in fractions of an inch. None appeared. The bridge had become what Bailey intended, a moving equation solved by pressure and balance. German observers on the ridge had not expected armor. Reports from the previous night described only infantry and trucks. The bridge's speed of completion defied every intelligence estimate. Before those reports corrected, the first 2 American battalions were already spreading across the meadows east of the river. The German command, realizing its error, ordered artillery to fire blind into the fog. At 0730, the first shells fell short. Columns of water burst upward and fell back as rain. Crews ducked behind ramps, counting seconds between impact and echo. Each gap meant another tank had crossed. The order repeated through field telephones: keep them moving. By 0800 hours, the crossing reached full flow. 60 vehicles per hour, 6 hours without halt. Every ton that reached the far bank tightened the line. The first German armor appeared through low smoke. Panthers and Stugs rolled from concealed positions behind the ridge. Their guns fired downhill toward the exits. 2 Shermans burned instantly, their turrets thrown aside. The rest advanced without pause, firing on the move. Behind them, artillery from the near bank switched to direct fire. Coordinates came in by radio, short bursts of numbers, each marking a square on the ridge. The river was now a line of pure geometry. Fighter bombers from 9th Air Force entered the field at 900 hours. P-47s descended through cloud and fired rockets into the tree line. The noise flattened the air. Smoke rose in vertical bands where German armor had tried to hide. Tanks below used it as cover and surged forward. The crossing was no longer a river. It was momentum taking shape in steel. By 1000 hours, more than 100 Allied tanks had crossed. The bridge held under continuous load. Technical data recorded in real time showed pin stress at 2,200 psi, deck deflection under 1 inch, temperature at 49 degrees Fahrenheit. The truss flexed but recovered perfectly. Under that vibration, one of the most complex battles of the campaign unfolded. German command tried to counterattack. 40 tanks formed a wedge and drove straight for the crossing point, intending to destroy the span before more reinforcements arrived. But the Allied timetable had already stolen their advantage. Artillery registered their route minutes before contact. Shells landed on grid 012 by 057, direct hits on the lead platoon. 3 Panthers stopped dead in the first volley. Rockets followed. The ridge burned in layers. From the air, smoke drew black spirals over the river valley. On the ground, gunners could see little but flame and reflection. The German attack faltered, then broke. Reports from forward scouts recorded the scene in numbers. 30 enemy tanks destroyed before 1100 hours, 50 by noon. Every 10 minutes, another wreck flared on the horizon. Still, the bridge remained the focus. At 11:30, a shell from an 88mm gun struck the midspan, tearing through a side truss and punching a hole in the deck. Traffic slowed, but never stopped. 2 sappers crawled onto the damaged section, sliding a replacement panel across on rollers. The water below threw light through gaps in the steel. They worked by touch, pinned the section, tightened both bolts, and climbed down again. The bridge did not pause for breath. By midday, the ground war rolled beyond sight. The ridge that had served as the last German line was silent except for burning fuel. Armor units fanned east, linking into their next phase route. Engineers logged the hour in quiet handwriting. Bridge operational, load continuous, no failures. Every entry reduced chaos to arithmetic. Captured maps later showed the German plan. Their assumption had been that Allied forces would need 48 hours to bridge the Rhine. The Bailey system cut that to 10. The gap in time destroyed coordination. Reinforcements arrived at empty fields already lost. The geometry of a bridge had rewritten the schedule of an army. As the day advanced, traffic changed from armor to resupply. Ammunition trucks crossed under smoke cover. Tankers brought fuel in 500-gallon drums. Field repair vehicles followed, their welders and cranes already hot. The bridge handled every weight, from jeeps to 30-ton Shermans without fatigue. Stress readings at pins stabilized near 2,000 psi. Engineers chalked the figures on a nearby crate as reference for later crossings. At 1400 hours, the last German counterattack dissolved. Fighter sweeps cleared the retreat routes. The far shore belonged entirely to the Allies. The bridge had carried 7 regiments, their support columns, and nearly 10,000 tons of equipment within 12 hours. The Rhine was no longer a frontier. It was a supply line. In the evening haze, the battlefield fell quiet except for burning tanks and the slow return of engines. Scouts walked among wrecks that steamed where rain met hot armor. Many Panthers had been caught mid-turn, their turrets locked by blast shock. The air smelled of cordite and diesel. Men moved without speech. The victory was visible in wreckage, not in sound. Near dusk, engineers began surface maintenance. Damaged planks replaced, pins greased, sand swept from the ramps. The bridge still carried traffic, now mostly trucks and ambulances. Soldiers leaned against railings, watching the red glow of distant fires across the plain. The river had carried them to a place that geography once forbade. German prisoners arrived after dark, herded across the same bridge their commanders had declared indestructible. They looked down at the deck beneath their boots, then at the far bank glowing with Allied fires. One asked a guard what the structure was called. The reply came in a flat voice. Bailey. The word meant little to them, yet it was the sum of what they had lost. At 2400 hours, the final log entry closed the day. Continuous load 22 hours. Maximum recorded deflection 0.8 inches. Stress within tolerance. No failures. The bridge stood where no bridge should have stood. The Rhine had been crossed not by chance or heroism, but by design repeated thousands of times until it could no longer fail. Across the east bank, 90 German tanks lay destroyed, some burned to frames, others sunk in mud where they had tried to turn. The night wind carried faint explosions as ammunition cooked off one by one. The flames lit the bridge from below, casting moving shadows along the truss. The engineers sat by their tools, eating cold rations. The war around them kept its distance. They had nothing to celebrate, nothing to repair. The bridge was still alive, humming under weight, steel cooling by slow degrees. It had done its work in silence and precision, as Bailey intended. Steel over water, math over myth. The river had been measured, crossed, and defeated. When the guns went silent, the bridge remained. It stretched across the Rhine like a scar, steel dulled by smoke, wood blackened by oil and frost. In the days after the battle, engineers stayed behind to keep the line open, while armor pressed east. Trucks rumbled across day and night, their tires grinding mud into the planks. By the time the front moved beyond sight, the structure had carried over 5,000 vehicles without a single structural failure. The Rhine crossing had been a test of numbers, and the numbers had won. Calculations written on a notepad in 1940 had carried divisions through the heart of Germany. Each joint, each pin, each 10-foot panel had proven that precision was stronger than prediction. Bailey's crazy bridge had crossed not only a river, but disbelief itself. When orders came to dismantle the secondary spans, the process moved with the same efficiency that had built them. Sections lifted from rollers, pins knocked loose, panels stacked in trucks. Within 2 days, the entire auxiliary bridge near Wesel was gone. Its parts reappeared 70 miles east across a canal near Dusseldorf, assembled by a different team under new artillery fire. Each rebuild confirmed the design's truth. Mobility was not an act, but a system. In the weeks that followed, bridges became a language of reconstruction. Bailey sections carried field hospitals, fuel convoys, and even refugee columns returning west. The same panels that had borne tanks now held civilians, wagons, and buses. Engineers logged every span in calm, clinical handwriting: length, load, time in service. They left no mention of who built them, only that they stood. By May 1945, Europe was stitched together by Bailey frames. From Normandy to the Alps, more than 5,000 bridges spanned rivers, craters, and canals. Factories in Britain, Canada, and the United States had produced 500,000 feet of steel sections in less than 3 years. Each was built to tolerance within plus or minus 1/16 inch. The same accuracy that built aircraft wings had built the war's hidden backbone. Donald Bailey was knighted that summer. The ceremony was quiet. No parades, no fanfare, just a medal, a photograph, and a brief line in the newspapers. He returned to his desk at the Ministry of Supply and kept refining his creation. His new sketches increased the load class to 60 tons, added reinforced joints, and simplified decking replacement. To him, the bridge was not a monument. It was still a problem to solve. After the war, the Bailey design spread across continents. It rebuilt bombed highways in France, spanned monsoon rivers in Burma, and replaced flood crossings in India. Each section kept the same stenciled code: bridge, portable, steel. Nations rebuilt faster because they had learned to think in panels and pins instead of years and budgets. The bridge that once carried tanks now carried progress. Technical records from peacetime showed its endurance unchanged. Average fatigue life of a panel, 10,000 stress cycles. Joint wear limit plus or minus 1/16 inch. Maintenance interval, 200 crossings before tightening. What began as a wartime invention became the foundation for civil recovery. Even into the 21st century, hundreds of Bailey bridges remained in use, their rivets worn but reliable. In museums, visitors see short, clean segments of its frame standing in quiet halls. They do not hear the hammer strikes, the cables singing, or the sound of engines above water. Yet the stillness hides its truth. The bridge was never meant to be admired. It was meant to work, and it did. The Rhine span was dismantled soon after victory. The river flowed unbroken again, carrying wood, silt, and traces of oil toward the sea. On its banks, soldiers packed tools, signed the final logbook, and wrote the closing line. Bridge number 5099, operational from the 23rd of March to the 2nd of May, 1945. Total load 80,000 tons. No structural failure. The war had redrawn maps, but this bridge had rewritten the limits of industry. It proved that speed, math, and design could defeat distance itself. No monument marked the site, yet the legacy remained. Steel born from logic, shaped by necessity, and trusted by every man who crossed it. By the winter of 1945, the front was gone, but the pattern stayed. Across Europe, Bailey bridges spanned silent rivers, each one a fragment of calculation turned permanent. No memorials marked them, no anthems named them, yet they carried everything left of the war, trucks of food, stone for rebuilding, and the first buses that moved through the ruins. Panels that had once held tanks now bore civilians crossing toward towns rebuilt from ash. The same geometry that crushed armies now reconnected their survivors. Engineers kept their habits, measuring deflection, tightening pins, recording dates in neat handwriting. To them, the bridge was never victory. It was function. Precision had outlasted emotion. Historians later called it the most successful military bridge in history. Bailey never used that phrase. He said only that it could be built by tired men in the dark. That sentence outlived every speech and photograph. It was the war's simplest truth. Effort turned into structure. They had not lost to courage or chance, but to mathematics, to a design so precise it left no room for failure. The bridge had made distance irrelevant. The river had never been the barrier. Doubt had been. 1940 conception. Donald Bailey drafts a modular bridge built from repeatable steel panels. Goal stated as build faster than it can be destroyed. Panel size targeted at 10 feet by 5. 1941. Prototype proof. Christchurch trials, an 80-foot span assembled by 10 soldiers in 2 hours. A 40-ton Churchill crosses without deformation. Class 40 rating proposed. 1942. Production standard. War Office approves mass manufacture with a universal gauge. Tolerance held to plus or minus 1/16 inch across suppliers. Kits boxed with truss, transom, deck, and pins. 1942. 1943. First field service. North Africa reports average assembly of 100 feet in 3 hours by a 50-man team. Reliability near 1,000 crossings per span before replacement. Heat and dust trials passed. 1943. U.S. testing. Aberdeen Proving Ground confirms load and deflection data for M4 operations. Maximum joint stress recorded near 2,000 psi under continuous load. Adoption follows June 1944. Normandy expansion. Hundreds of bridges close gaps from beachheads to the Seine. Logistics notes compute advanced speed in feet of bridge per hour, not miles per day. Late 1944. Industrial scale. More than 500 subcontractors in Britain and Canada deliver panels to a common gauge. Monthly steel consumption passes 120,000 tons by factory records. March 1945. Operation Plunder. Multiple Bailey spans launched under fire on the Rhine. Armor crosses within hours. Allied reports log 90 German armored vehicles destroyed within 1 day east of the river. April-May 1945. Continuous service. Primary Rhine spans carry mixed traffic for weeks. Logbooks record deflection under 1 inch at midspan and no structural failures under continuous load. 1945. Total system footprint. More than 5,000 bridges erected across theaters. Linear length surpasses 500,000 feet by year-end, 1946. Recognition. Donald Bailey is knighted for wartime engineering service. Post-war notes target Class 60 upgrades and reduced pinware. Post-war civil legacy. Bailey sets rebuild roads and river crossings on 5 continents. Peacetime studies record panel fatigue life near 10,000 cycles, with maintenance every 200 crossings.